Okay, so this is lecture 4, and we're going to be talking about variables, constants, and data types. So we've talked about a lot of this already, but we're going to talk about it more. And we're also, probably won't do this part here. At the end of today's class, I will assign you 2 new tasks, a body mass index calculator and a simple interest calculator. Okay, so in this lecture, we're going to talk about storing data, how data is stored inside the computer. And we're going to talk more about data types. We talked about integers and doubles. We're going to also mention singles, this type here, and string we talked about, and also this type here. We're also going to talk about variable scope, which means if you use a variable inside like one button, can you use the same variable inside another button? Generally, the answer is no, but anyway, we'll talk about that. And we're talking about formatting data for output. And we'll use the Visual Studio to apply this formatting that we study to our price calculator, which we had before. Okay, so let's talk about how computers store data. So let's see, if I write this number 27, if I write this number 27, everybody knows what that means, of course. And we can say that it means 2 times 10 plus 7 times 1, right? And if I wrote 527, 527, we could say that equals 5 times 100 plus 2 times 10 plus 7 times 1. And if I had 6,527, I could say that's 6 times 1,000 plus 5 times 100 plus 2 times 10 plus 7 times 1, and so on, right? This is called the decimal representation of the number. So 27 is a decimal representation. Decimal comes from the word, where does it come from? The word it comes from a Latin word for 10. So it has to do with 10. So this is 10 to the 0, 10 to the first, 10 to the second, 10 to the third. We say we have a 2 in the tens place. If the number again was 527, we'd say we'd had a 5 in the hundreds place. This is the thousands place. This is the 10,000ths place. So we can go on like that. However, sometimes another way to represent numbers is by using the binary representation. So instead of tens here, these are powers of 10, right? 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth, and so on. Instead of doing it that way, we could write powers of 2, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and so on. And the first one we have is 10 to the 0. First one we have here is 2 to the 0. So if we wrote this number, 11011, what that would mean is 1 times 2 to the 0, in other words, 1 times 1, 1 times 2 to the first, it's 1 times 2, 0 times 2 to the second, so we don't need that one, and 1 times, we don't need that one. We need it here, but we don't need it. I don't need to include that here in the calculation, although actually, if I was making these slides, I would have put 0 times 4 here. Anyway, 1 times 8 and 1 times 16. Okay, so another way to represent the same quantity, the quantity was represented as 27 when we expressed it in decimal notation, but here it's represented as 11011. Okay, so this is called binary representation for the same quantity, as this was 27 was the decimal representation of that quantity. Notice also that in decimal representation we have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and in binary we have 2 digits, 0 and 1. So you don't go higher than that here. Okay? So, okay, so let's read what's written here. Computers store data as bits. So we can store this, instead of storing it this way, as 27, I could store it as 11011. And then if I had some circuit that was either on or off, or many different circuits that were either on or off, I could have the first circuit be on, second circuit be on, the third circuit be off, the fourth circuit be on, and that would represent 11011. In other words, that would represent the quantity 27. Okay? And these are called bits. If something that is expressed as either a 0 or 1 is called a bit. So computers store data as bits. Here, bit is short for binary digit. A bit can take only two values, 0 or 1. So we saw that. This bit can only be 0 or 1. This bit can only be 0 or 1. This bit can only be 0 or 1, and so on. A number may be expressed as a string of bits, or just a better word would be a sequence of bits. String makes us think that we're talking about text. We're not. So just a sequence of bits, where each bit represents a power of 2, right? So 1 here means 1, 2 to the first. This means 0, 2 to the seconds. This means 1, 2 to the third. This means 1, 2 to the fourth. Okay, where each bit represents a power of 2, or called base 2. This is referred to as binary representation. So again, this would be called the binary representation of the quantity 27. So 1, 1, 0, 1, 1 would be called the binary representation. Note that there are 8 bits in the binary representation above. In other words, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are all zeros, but we'll still look at chunks of 8 of these. Chunks of 8 of these as well, but that's not binary. And we call 8 bits, this is 8 bits, we call that a byte. So a byte, which equals 8 bits, is a common unit for measuring computer memory. So computer memory, here we have 8 bits. There are 8 like little circuits that can be either off or on. And so we have 8 of them. We say we have 8 bits.